13-3 is on trigonometric functions of general angles, and right here I just have sine, cosine, tan, cosecant, secant, and cotangent, and I've shown you with this little point right here. This is the point x, y. This will be the x, this will be the y. So then if this is theta, x is your adjacent, y is your opposite, and then we're using r, that's the radius, would be your hypotenuse. So I've just gone in and anywhere that we used opposite as the y, anywhere hypotenuse as the r, and anywhere adjacent was an x. So it's the same idea, it's just using those three letters. One thing to point out here is where I have that these can't equal 0, the denominator just can't equal 0 on anything, that's why that's written there. But one thing that you also need to know is that this little formula right here is very helpful. So it's basically Pythagorean theorem. So instead of saying r squared equals x squared plus y squared, we've just gone ahead and taken the square root. So you can plug that in. Example 1 says the terminal side of theta in standard position contains a point at -6, 2. Find the exact values of the 6 trig functions of theta. So our job will be to fill in each of these 6. What I would suggest is just to the side, writing what x, y, and r are. So x is -6, y is 2, and then let's use this formula to find r. And that's kind of, I cut that off a little bit, so I'm just going to move over. But r equals the square root of x squared, so -6 squared plus y squared, which is 2 squared. -6 squared would be 36, plus 2 squared is 4, so that's 40, square root of 40. And since it says exact, we don't want a decimal, so if you break down, sorry, again, I'm writing off the screen. If you break down 40, that will be what, 4 and 10, 2 and 2, there's your pair, and then 2 and 5, that wouldn't be a pair. So this would end up being 2 radical 10 for your r. So now we have our 3 exact values to be able to plug into these 6 right here. So sine theta equals cosine theta equals tan theta equals, and then cosecant, secant, and cotan. And we're just going to fill these in with our x, our y, and our r. Sine is y over r, so that would be 2 over 2 radical 10. Well, the 2's would cancel, which is 1 over radical 10, multiply radical 10 over 10, and so our answer is radical 10 over 10. Sorry, I wrote that really small. Radical 10 over 10. Cosine, x over r, so it'd be -6 over 2 radical 10. 2 would cancel, that would become a 3, times radical 10 over radical 10. So we get -3 radical 10 over 10. -3 radical 10 over 10. Tan is y over x, so 2 over -6. We just reduce, that'd be -1/3. And then for cosecant, it's r over y. You can also just flip it, but since we changed these, I'm going to go ahead and do it again. So r over y, that's 2 radical 10 over 2. Well, the 2's cancel. Our answer is radical 10. For secant, r over x, 2 radical 10 over x is -6. So the 2 would cancel, make that a 3. So it'd be negative radical 10 over 3. And then cotangent x over y, -6 over 2, which reduces to -3. And that's, again, if you look at it, that's opposite. -1 over 3, well, that would flip to -3 over 1. So again, you could choose to just do the reciprocal, or like I just did, plug it in again. Next is the definition. If the terminal side of an angle theta in standard position lies on the x or y axis, the angle is called a quadrantal angle. And I'm probably not saying that exactly right, but quadrantal angle. Think of it like a quadrant, and that's where the word comes from. What that means for our purposes is one of the numbers x or y will be 0. So in our next example, you're going to see that that y is 0. So again, x is -2, y is 0. We're going to find r. R equals the square root of -2 squared plus 0 squared. Well, -2 squared is 4. 0 squared is 0. So that's the square root of 4. So r equals 2. So then we just plug it in. So sine theta is y over r, 0 over 2. 0's on top, so it's just 0. Cosine theta is x over r, so negative 2 over 2, which reduces to negative 1. Tan theta, y over x, 0 over negative 2, so 0 on top, that's just 0. Cosecant theta, r over y, 2 over 0. Well, you can't have a 0 on the bottom, that is undefined, so no solution or undefined. Secant theta, r over x, 2 over negative 2, which equals negative 1. Cotangent theta, x over y, negative 2 over 0. Again, can't have 0 on the bottom, it's undefined, or no solution. So with a quadrantal angle, you're just going to notice that sometimes we have zeros as answers, as well as a no solution. If theta is a non-quadrantal angle in standard position, its reference angle, which we call theta prime, I've written that right here for you, just theta with a prime, is the acute angle formed by the terminal side of theta and the x-axis. So we've talked about this just a little bit, I think, this year, but the idea is it's just the part from the terminal side to the x. So you wouldn't go all the way around, we're just worried about just the small piece right there. And again, this is just in my own words how to do it. Find the closest distance to the x-axis. For example 3, we're going to sketch each angle and find its reference angle. Degrees happen to be a little easier than radians, but you can do it for both. Negative 110 degrees would go the opposite way, 90 and a little bit more. So this would be the negative 110. So what you want to think about is the closest way back to the x. Well, is the closest way to go back 110 degrees or just to keep going this way? And this will be the closest. So we label that theta prime. And how I like to think about it is if this whole thing is 180 and I already used up 110, I'm going to subtract that. That's just the easiest math for me to do, and find that theta prime is 70 degrees. So the reference angle is theta prime, which is 70 degrees. Another option would be, we know that every quadrant is 90. So if we already used 90 here, then this would be 20, and 90 minus 20 is also 70. So there's a couple ways to think through it. For B, we have 2 pi over 3. Again, I don't think in radians very well. If you flip back over in your notes to the unit circle, you could just do it that way. But so that to save a little time, I'm going to change this to degrees. Again, we learned this last section. 2 times 180 is 360. The pi's cancel over 3, which is 120 degrees. It's just easier for me to think that way to draw it. So I start at 0, go 90, 120. So this would be where my line is. And this would be 120 degrees, which is 2 pi over 3. The reference angle would be the closest way back, which is closer just to keep going than to go in reverse. So this would be theta prime. Now, again, same idea. If this was 90, then we use 30. So there's 60 degrees left. One thing, though, is if it's given in radians, we want to answer in radians. So I'm going to need to go and change that degrees back to radians. Again, you could use your unit circle. And that's 60 pi over 180, which that reduces to 1 over 3, so pi over 3. So my reference angle is pi over 3 right here for theta prime, which again is just the closest way back to the x-axis. The last part of section 3, which I find to be really helpful, again, just like the unit circle, it's worth memorizing at the same time, but it's just evaluating trig functions. So these are just 3 steps. Step 1, find the measure of the reference angle, theta prime. That's what we did here. Step 2, evaluate the trig function for theta prime. And step 3, determine the sign of the trig function value. Use the quadrant in which the terminal side of theta lies. So like where the pink arrowed line is, that's what quadrant. If you don't remember, this is quadrant 1, and then you go counterclockwise. 1, 2, 3, 4. And all I'm showing you right here is for sine, cosine, and tangent, whether they're positive or negative. So in quadrant 1, they're all positive. In quadrant 2, sine is positive, cosine is negative. And then anytime these are different signs, tan will be negative. If they're the same signs, it's positive, because tangent is just sine over cosine. Another thing I like to think about is sine goes with y, cosine goes with x. We kind of talked about that just a little bit ago in this lesson. but that will also help you figure out the signs as well. Because y, this is the y-axis, so y is positive up here, so sine is positive up here, negative down here. Same thing for cosine being x. Well, this is the x-axis, so cosine would be positive, x over here, negative over here. And then just knowing that tangent, if sine and cosine are the same sign, it's positive. If they're different signs, it's negative. For example 4, our job is to find the exact value of each trig function. While we could use our calculator and just type this in, that wouldn't be exact necessarily. So I want to show you with the unit circle. So cosine 135. If you look at the unit circle, find 135. This will be the angle that you're referencing, okay? I just have the basic unit circle here, but when you memorize it, a lot of times beside each of these, you have an X and a Y coordinate, and then you could use what we just learned in this lesson, knowing X, Y, and then finding R, to be able to use the unit circle that way. So you'll get better at that the longer you practice with these, but I just wanted to show you that unit circle is really the easiest way to reference these. Now, cosine 135. If you think about it like this, it would be here, this would be 90, so this is 45. So my reference angle, theta prime, is a 45-degree angle. Well, what we know about 45-degree angles is that they have that perfect right triangle, x, x, x radical 2, and you use that to be able to solve. Your book also has another helpful chart on page 827, this one right here. So this is what I'm going to be referencing just to help you see like what the exact values are. Again, these would be worth memorizing, but you memorize them with the unit circle. So don't just memorize this chart. When you get to do the unit circle, just memorize the whole thing with those values. Okay, so again, I'm looking at that chart, which is beside me in our book on page 827. So if I look, I know that it's going to be 45 degrees. So if I look at my chart, cosine of 45, it's radical 2 over 2. So that helps me know what the exact value is. Again, like I was saying a minute ago, cosine 135, if I type that in, I get this negative, this decimal. So if I do radical 2 divided by 2, I get that same decimal. Okay, sorry, the light's kind of helping. So that's kind of the idea. You can still check it with your calculator, but this is the exact value. However, 135 is in the second quadrant. So we look at the second quadrant, cosine is negative. So my answer is negative radical 2 over 2. And if you noticed in the calculator, that's what we got when we typed it in. So that's also going to be helpful to get those signs right if you do want to use the calculator. For B, it's 5 pi over 6. Again, let me just show you. Rather than having to do the math, you could find 5 pi over 6. Okay, that's 150 degrees. See how the unit circle can already help you even with just the basic one. So this is tan of 150. Again, if you want to draw it out, 90, you'd go another 60 to get here. So theta prime would be 30 degrees to get the rest of the way. So then this one is a 30, 60, 90. So x, x radical 3, and 2x. And again, that's kind of the basis for how the unit circle gets its values. Again, I'm going to be using the chart. So I'm going to do tan of the 30-degree angle. So looking at the side in my book, tan of 30 is radical 3 over 3. I want to show you that typing in tan of 150 gets me this decimal. And if I type in radical 3 divided by 3, I get the same decimal. Notice it says it's negative. Okay, well, let's check our chart. This is, again, the second quadrant. Second quadrant tan is negative. So that's how this chart is helpful to get that sign.